Alright guys, so welcome to our channel once again today to learn about electric field. So an electric field is a region around the body where the electric force of that body can be felt. Now an electric field can be represented by lines of force. So the lines of force in an electric field will show the path along which the free positive charge will move in the field. So I'd like to use this simple illustration. Now, this will show the path along which the positive charges will move in this field. Now notice that the positive charges tend to move away from the midpoint. Why? Because this is positively charged. Now, on the other hand, if this is negatively charged, now let's recall that unlike charges tend to attract. Now, as such, the free charges tend to move towards this direction. So we said that the direction indicating a line of force is the direction along which a free positive test charge will move. So now this indicates the direction which the free positive test charge is moving. Whereas on this other hand, you can see that the free positive test charge will move towards the center or midpoint because this is negatively charged and this is positively charged. Alright. So the electric field intensity E at a point in an electric field is the force experienced by a unit positive charge placed at that point. Now, the electric field intensity is denoted by the symbol E, and E is equal to L over Q, where L is the force, and then L is the force, and then Q is the charge. Alright. So let's bring this into consideration again. Now, if I have these field lines, now let's assume that I have my positive charge here, and within this is O, and then along this region I have my P at the end here. So now these are 2 points within this field line. Now the distance between them will be R. So if we consider this, and let's say there is a point charge at this region Q, actually a positive point charge, and then let's say there is a force acting on a positive test charge around this point P. So if I have a positive test charge here, I can actually tell the force acting around or acting on this positive test charge with the Coulomb's law. Let's say we can recall the Coulomb's law that the L or the force will vary as the product of the two charges, and then will vary inversely to the square of the radius. Alright, so with this, since we already have this Coulomb's law, we can also have this to be that L is equal to the Coulomb's constant times the product of the charges over the square of the distance between them. So let's recall that we have the Coulomb's constant to be 1 over 4 pi epsilon naught. Now with this, we can simply state L to be 1 over 4 pi E naught times the product of the charges over R squared. Now we'll multiply this out. We'll have 1 times the product of these charges will give you the product of the charges, and then 4 pi E naught times R squared will give you 4 pi E naught R squared. Alright, so we'll simply have our F to be equal to Q times Q over 4 pi E naught R squared. So let me go ahead and wipe this and then bring this up again. So L is equal to this So let's also recall that previously we defined the electric field intensity as L over Q. Now, since we defined this electric field intensity to be this, we can actually derive L from this, or simply make L the subject of the formula from this. So when we cross this, we have L is equal to E times Q, or simply put, L is equal to Q times E. So here now we have two equations. L is equal to Q times Q over 4 pi E naught R squared, and L is also equal to Q times E. So let's go ahead and wipe these parts. So now we are going to equate these two. So this is L and this is also L. So it means that this is equal to this. So when we get this down, let's say Q times E is equal to Q times Q over 4 pi E naught R squared. Now we can simply make E the subject of this equation by dividing this by the coefficient of E here, which is Q. So we can simply say E is equal to Q times Q over 4 pi E naught R squared divided by the coefficient of E, which is Q. So when we do this, this will simply give us Q times Q over 4 pi E naught R squared now times the inverse of this, or the reciprocal of this, which is 1 over Q. Now the reason I'm using the reciprocal of this here is because of the change of the sign here. Now notice that I changed my division sign to a multiplication sign here. So I'll have to use the reciprocal of this. So now at this point, I can simply go ahead and cancel off Q and Q. Now therefore, E becomes Q over 4 pi E naught R squared. Alright, let's go ahead and wipe this. So next we'll talk about electric potential. So electric potential V at a point in an electric field is the work done to move a unit positive charge from infinity to that point. Now the electric potential at infinity is assumed to be 0. So before we proceed, there's something I'd like you to keep in mind, that work is force times distance. Now we'll make use of this later. So now let's recall that we have defined electric potential V as the work per unit positive charge. Hence, we know that work is force times distance from this. But then, if we consider the work done in moving a charge or an electric charge from one point, perhaps infinity, to a point on the electric field, we can see that the work is this force times distance R where we can state our force to be Q times Q over 4 pi E naught R squared. So if we multiply this by R, let's say Q times Q over 4 pi E naught R squared times R. Now, let's multiply this out. We'll have Q times Q over 4 pi E naught R squared. Then this times R is R. So we'll simply go ahead and divide this. This leaves this as R. So we'll simply have Q times Q over 4 pi E naught R. Alright. W now becomes Q times Q over 4 pi E naught R, or simply put Q times Q over 4 pi E naught R. Now, since the electric potential V is given by W over Q, we can simply replace W by this, and then we say V is equal to, now W, which is this, that's Q and Q over 4 pi E naught R, now divided by Q, which actually, you know the normal way, if I change the division to multiplication, I'll have 1 over Q, and then this leaves this as Q over Q over 4 pi, Q times Q over 4 pi E naught R, now times Q, while this is multiplied by 1, which still remains as this. Now, if I go ahead and divide this out, this gets cancelled, and then I have V as equal to Q over 4 pi E naught R. So in our next class, we'll see how we can make calculations on electric field. So guys, if you enjoyed this video, please go ahead and give it a thumbs up. Also ensure to share and subscribe to our channel. Thank you.